Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. The Younger Dryas in Africa, etc. The year 2019 has had a remarkable number of publications about the Younger Dryas Impact Hypothesis and the associated platinum anomaly that was first reported in 2013 by several researchers from Harvard University who examined Greenland ice cores. 4 different papers published in 2019 confirmed a platinum anomaly in various locations around the world at the Younger Dryas boundary approximately 12,800 years ago. The publication by Pino et al. Found evidence of a platinum anomaly in an extinction event in Chile, South America. The paper by Moore et al. Examined sediment cores from White Pond in South Carolina and found assorted proxies for an extraterrestrial event, including platinum at the Younger Dryas boundary. The paper by Thackeray et al. Examined a late Quaternary archaeological site in South Africa with peat deposits extending back more than 30,000 years and found a platinum anomaly at the Younger Dryas boundary. The paper by Teller et al. Looked at sedimentary sequences in Manitoba, Canada, near Glacial Lake Agassiz, and found elevated platinum levels at the Younger Dryas boundary. These 4 papers support the hypothesis that an extraterrestrial impact approximately 12,800 years ago triggered the Younger Dryas cooling event and injected platinum-rich material into the atmosphere that became distributed at many locations throughout the world. The extraterrestrial event is associated with the extinction of the large animals that lived in North and South America, but not in Africa. The paper by Pino et al. Examined a site in southern Chile at a latitude of approximately 40 degrees in the southern hemisphere. A previous video described this research in greater detail. One of the important findings of this paper was a platinum peak at the Younger Dryas boundary layer. The layer also had an anomalous platinum to palladium ratio, suggesting an influx of known local platinum. And the ratio of gold to platinum was also elevated, suggesting an increase of known local gold. The stratigraphic distribution of megafaunal bones and dung fungi spores corroborated the extinction of the South American megafauna at the Younger Dryas boundary. The paper by Moore et al. Examined White Pond in South Carolina and reported a large platinum anomaly and an increased platinum to palladium ratio at the Younger Dryas boundary. In addition, the researchers also found a decline in spores associated with dung from large animals, which is consistent with the megafaunal extinction 12,800 years ago. This is a LiDAR image of White Pond near Elgin, South Carolina, showing the location where cores of the sediment were collected. Geologists sometimes need to get wet and dirty as part of their job, but it is all for the sake of science. These pictures show a raft being launched with the coring equipment, and scientists obtaining the cores from the bottom of the lake. White Pond is a shallow lake that covers nearly 26 hectares and has a depth of less than 2 meters in the deepest portions. This image shows the White Pond core layers with a Bayesian age to depth model. The platinum content is charted as a red line and the ratio of platinum to palladium is indicated with a blue line. The paper by Thackeray et al. Explores Wonder Crater, which is a spring and peat mound site situated in the interior of southern Africa that has an extensive record of climate change and human occupation. The paper reports a Younger Dryas platinum spike that supplements the discoveries in South America and more than 25 other sites with platinum anomalies in the northern hemisphere. This map shows the location of Wonder Crater in South Africa in relation to other Younger Dryas sites that also have anomalies in platinum concentrations in deposits dated to approximately 12,800 years ago. The orange dots show sites with platinum anomalies, and the red dots represent sites with other impact proxies such as microspherules and nanodiamonds. This table shows the platinum concentrations at various relative depths in Wonder Crater. The highest concentration of platinum is found at a depth of 360 centimeters. The upper graph correlates temperature against depth and age. The bottom chart displays the platinum concentration at various depths and links the platinum spike to the onset of the Younger Dryas. The paper by Teller et al. Analyzed the sediments of Glacial Lake Hind, which is located about 40 kilometers west of Glacial Lake Agassiz. Glacial Lake Hind formed in a small ice marginal basin during the retreat of the Laurentide ice sheet. sediments deposited in the Lake Hind Basin are exposed along the Surrey River. This image shows the glacial Lake Hind region with the major rivers and lake basins. The extent of glacial Lake Hind is shaded. These graphs show the concentrations of nanodiamonds, platinum, iridium, and the sediment grain sizes. The platinum concentrations measured in this study show the broad increase across the Younger Dryas boundary, with concentrations continuing to rise into the peat section, presumably due to selective plant uptake of platinum group elements. The worldwide distribution of platinum makes it very clear that the Earth was impacted by a platinum-rich meteorite approximately 12,800 years ago, causing a great cataclysm that resulted in the extinction of the megafauna in North and South America. Although the platinum anomaly has been found in Africa, this continent was able to retain its megafauna. There are some lingering questions. What killed the megafauna? Was it the onset of the Younger Dryas cold event, or was it the impact? We note that the extinction did not happen all at once, since there is evidence of mastodons living much later than the cataclysm, and buffalo were able to survive away from the impact site. Where is the crater? Thus far, there is no crater or primary evidence of shock metamorphism. All these studies are dealing with microscopic proxies that are widely distributed throughout the world and do not help to pinpoint the location of the extraterrestrial impact. But the megafaunal extinctions in North and South America constrain the location of the ET impact to the Americas. How about the Carolina Bays? The Carolina Bays and the Nebraska rainwater basins converge by the Great Lakes, and this is a strong hint that this was the location of the extraterrestrial impact. Researchers of the Younger Dryas Impact Hypothesis have deliberately excluded the Carolina Bays because it has been difficult to determine their mechanism of formation and to reconcile the diversity of dates associated with the bays. This may all change in the future because the elliptical geomorphology of the Carolina Bays is proof of their impact origin, and the diversity of dates can be explained as the dates of the terrain because dating methods intended for sedimentary processes should not be applied to impact structures. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.